Hi guys, Mr. Bennett here. Today we're going to be looking at acceleration, and I want to first of all go through some formulas with you. First of all, I just want to refer you to your formula sheet that you were given in day one. So remember, your formula sheet is the one that you get in the Year 12 exam. It's got all the values on there, so it's got the symbols, okay, that you will use and what they relate to. It's also got some constant values that you need. Okay, we'll find out that you'll use those later in the year and certainly in Year 12. And then we've got the formulas, and generally these are the ones that you'll use in Year 11, the motion in 2 dimensions or 1 dimension. So I just want to relate you to these formulas over here. So these are the formulas that relate to when you change the velocity. And if you rearrange this one here, this is in fact the change in velocity over the time. Okay, you can rearrange that to that form there. There's a second formula which relates final velocity, initial velocity in the acceleration, the displacement. And this one here also relates displacement, initial velocity in the acceleration with the time. So what we're saying here is the velocity at any time t, and that's velocity at time 0, so now in other words initial velocity. With this one here, the change in velocity, we're going to use Vf and Vi for initial velocity. Okay, so obviously the average velocity is the change in velocity over time. Okay, so these formulas are here for you, so you don't need to actually remember them, you just need to know how to use them. Alright, so that's our skill that we'll be looking at. So just reiterate those formulas. Obviously A is the symbol for acceleration. So we're going to use V, take V0 all over T. You may also write that as V final, take V initial over T. Alright, so I don't really mind either. Those are both okay. And sometimes in a physics book you might see V take U, okay, where U is the initial velocity. Right, so it's just the change in velocity. Right, so that's one of our formulas. Okay, probably the first formula you had was when you don't change your velocity, don't change or don't accelerate, we can say velocity is equal to displacement over time. So we'll call this one here formula number 1, this one here formula number 2, formula number 3, we'll call this one here, we'll say that V is equal to V0 plus A times by T, and that's just the rearrangement of this formula into another form for you, so you can find the final velocity. Okay. Alright, so you also might see that one written as V final equals V initial plus A times by T. Alright, so, but I think we should be consistent with the formula sheet because that's what's on there. The next formula that we're going to do here is saying V squared take V0 squared is equal to 2A times by S. Now remember, S is displacement. And then the last formula we're going to use in physics, and this is pretty well what we'll use throughout most of the first semester, is this one here which says that the displacement is equal to V0t plus a half of AT squared. Alright, so they are the 5 formulas that we will use throughout the physics. Now, remember in the previous video I talked about the problem solving strategies. Obviously if we don't have any acceleration you probably use formula number 1, but as soon as you have an acceleration or change in velocity you're either using 2, 3, 4 or 5. So you'll need to look at the values that you have, the information you have and what you want to find, and then you can actually do that. So if we look at this example here, so what we've got here is a drag car reaches a speed of 500 kilometers per hour in 6 seconds. What is the acceleration? So again, you know, I just talked about being consistent with what we're doing here. We might work in blue today. Right, so we need to identify some information there. Now, I am going to highlight that. I'm going to highlight that. It's pretty important. And then that's the thing that I want to find. Generally, that's the last thing you'll see on there. So we can write these things down. So what's this? Well, a drag car reaches a speed of 500 kilometres per hour. Well, that is going to be my final velocity, is 500 kilometres per hour. Now, what I should do is I should convert that to metres per second. So remember, converting it to metres per second, I have to divide by 3.6. Okay, so if I do that, I'll go to my calculator. Hopefully it'll work. Oh, it's taking its time. We'll do that later. Alright, so we'll continue on. So that's my final velocity. The information there, it's not obvious what you've got, but if you've got V0, what's my initial velocity? Well, we're starting with 0 metres per second. Right, that's what we've got as our initial velocity. Okay, so the next thing I need to do is I need to know the time, or the time it takes to do that is 6 seconds. And then the thing that I want to find is my acceleration. So I've got all my information down here. What I need to do now is I need to go and pick a formula. Now, this one here has got acceleration, final velocity, initial velocity, and my time. So clearly, I'd be best to use formula number 2. So in this particular case, I'm going to write down my acceleration is equal to my final velocity, take my initial velocity, all over t. Okay, now I'll need to just do that, and my calculator's not working on the computer. So I'll just do that on another one. Give me 2 secs. So 500 divided by 3.6 is equal to 138.9. I'll be close enough. So 138.9, and that's metres per second. Alright, so I'm going to put that value in there, 138.9, take away 0, all over 6. So when I divide that, so that's going to be it's going to give me something like 23.15. And that's metres per second squared, isn't it? And so therefore that's acceleration. And then you'd probably give a direction, probably say which direction it's going in, but it hasn't in this particular case. But you get the idea of how to use that formula. Let's look at another one. So an airplane lands on a runway with a speed of 700 kilometers per hour. It takes 12 seconds to stop. What is the deceleration? Right, so again, some information I need to highlight. So I've got my 700 kilometers per hour. I've got 12 seconds of time. I need to work out my deceleration, don't I? Okay, again, this one's got a hidden bit of information here. So we know our initial velocity, V0, is equal to 700 kilometers per hour. Got to convert that to meters per second. So do that. That will give me an answer of equal to 194.44. Right, so you've got to make sure everything's in the right sort of units. What's my final velocity? Well, my final velocity is going to be stationary, 0 meters per second. Doesn't tell you in the question, but it sort of does. Okay, my time taken for it to stop is 12 seconds. And then I'm working out my acceleration, or deceleration is just negative acceleration. So again, I'm going to use the same formula. A is equal to V take V0 all over T. Okay, so this is the math part of physics, which is, it's not that hard, the math that you have to do. So that's going to be 0 take 194.44. Divide that by 12 will give me an answer of 16.2. So that's going to give me negative 16.2 meters per second squared. So you say that's the case, or you could say 16.2 meters per second squared deceleration, because that means the same thing. So when we get negative, we know we're actually decelerating in that particular case. All right. So now